All right, our last set of solving questions, our last piece of information here is two more vocab words. So we have a circle, and our vocab word here is inscribed in a shape or a polygon if each side of the polygon or shape is tangent to the circle. So that would be something like you have a triangle like this, and then you draw a circle in it, and it happens to touch all of the sides at exactly one point of tangency there. So that would be, again, the word for this is inscribed. And that tells us quite a bit about this, because if it's tangent, then these lines are all meeting at one point, and we're going to be able to say a lot about the properties. So like this equals this. We can say that this side equals this side, and this side equals this side. And to be even more clear, we can shade this. So like this segment is the same as that segment. And same thing from here to here. And then same thing from here to here. So you're going to be able to solve for, in this case, some missing values. So let's say, for example, they tell you that this is 10, and let's say this is 5, and this whole length from here to here is 12. And they want you to solve for, let's say, x right here. Well, based off of the properties that we did in the above question, we also know that this length here has to be 10. We also know that this length here has to be 5. So we're basically trying to figure out, what is this length? Well, x and that length are the same. And we know, in this case now, x plus 10 equals that entire length of 12. So again, to go from all the way up there and across. So it allows you to solve for different lengths. So we can say, okay, this length here is 2, that length there is 2. So that is why inscribed is powerful, is because basically you can get sides that are congruent and use it to solve for unknown quantities in whatever the polygon or shape is that's on the outside of the circle. A second example that's going to come up is something called circumscribed. So a circle is circumscribed if each vertex of the polygon or of the shape lies on the circle. So that would be something like this. You just have like a quadrilateral, 4 sides here, and it just happens to have its edges on the side of the circle. So based off of our properties, we're not going to be able to tell quite as much about a circumscribed shape as we are about an inscribed shape, but again, still some good vocab words to help us differentiate. So the examples that you're about to see coming up are going to be more of this setting equal to each other, inscribed circle type questions. All right, everybody, thanks for tuning in. As always, questions, let me know, email, Teams, all of that stuff. We are here to help. We want you to do well. I'll see you in class very soon, as always.